Not theories, not legends, but physical structures that are standing right now, all around the world. These buildings were constructed thousands of years ago without steel, electricity, engines, or digital measurements. Yet many of them outperform modern structures in durability, precision, and resistance to time. Modern engineers study them, measure them, test them, and often admit something uncomfortable. They don't fully understand how they were built. Let's start with precision. At sites like Machu Picchu, Pumapunku, in the Giza Plateau, stone blocks weighing tens or even hundreds of tons were cut and fitted together so perfectly that not even a razor blade can slide between them. No mortar, no cement, just stone on stone, locked tighter than most modern concrete. Today, achieving this level of precision requires laser measurements and diamond-tipped tools, yet ancient builders did it with tools we're told were primitive. Granite is harder than steel. Cutting it precisely is difficult even now, yet ancient civilizations shaped granite as if it were soft clay. In Egypt, massive granite blocks were quarried hundreds of miles away and transported to construction sites with no visible damage. They were placed with near-perfect alignment, often to astronomical precision. The Great Pyramid is aligned to true north with an accuracy modern buildings rarely achieve. This was done without GPS, satellites, or modern surveying tools. Engineers still debate how this was possible. Then there's scale. The stones at Baalbek in Lebanon weigh over 1,000 tons each. Modern cranes struggle to lift even half that weight, yet these stones were cut, transported, and placed with precision. No clear explanation exists. Some theories suggest ramps, others suggest levers, but none fully explain the efficiency, accuracy, and scale involved. Now consider earthquake resistance. Ancient structures in Peru, Japan, and Greece survive earthquakes that destroy modern buildings. Their secret lies not in rigidity, but flexibility. Stone blocks were shaped to interlock, allowing movement without collapse. When the ground shakes, the structure moves, then settles back into place. Modern engineers call this advanced seismic design. Ancient builders mastered it thousands of years ago. Roman construction presents another mystery. Roman concrete grows stronger over time. Modern concrete weakens, cracks, fails. Roman harbors built over 2,000 years ago remain intact despite constant exposure to seawater. Scientists discovered that volcanic ash reacted with seawater to strengthen the concrete over time. Even now, modern industry struggles to recreate it at scale. Then there are arches and domes. The Roman Pantheon has the largest unreinforced concrete dome in the world. It has stood for nearly 2,000 years. Modern engineers admit that if it were built today using the same methods, it would likely collapse. Ancient builders understood weight distribution intuitively. They reduced mass where it wasn't needed. They reinforced where pressure accumulated. This wasn't trial and error, it was knowledge. In ancient India, massive temples were carved from single pieces of stone. Entire structures were sculpted top-down, not assembled. One mistake would destroy years of work, yet they succeeded. Repeatedly.
How did they plan it? How did they visualize it? We don't know. In Cambodia, Angkor Wat uses precise stone placement combined with water engineering. The surrounding reservoirs regulate groundwater, preventing structural collapse. Modern engineers only recently understood how critical this system was. Ancient builders didn't just build structures, they built environments. Now consider time. Some ancient structures show minimal erosion after thousands of years. Others appear younger than expected. This suggests materials and treatments we no longer use or no longer understand. Ancient builders often aligned structures with celestial events, solstices, equinoxes, planetary cycles. This required long-term observation across generations. It required accurate record-keeping. It required patience. This was not primitive behavior. It was advanced planning. So where did this knowledge come from? Ancient builders didn't write instruction manuals the way modern engineers do. Their knowledge was passed orally, through apprenticeships and through practice. When civilizations collapsed, this knowledge vanished. Wars destroyed cities, libraries burned, experts were killed, entire construction traditions disappeared. The Library of Alexandria may have contained architectural knowledge we never recovered. What followed was not progress, but regression. For centuries, humanity built weaker structures than those that came before. Only recently has modern engineering begun to rediscover principles ancient builders already understood. Resilience over rigidity, balance over force, harmony with nature over domination of it. The uncomfortable truth is this: ancient civilizations were not less intelligent, they were differently intelligent. They studied materials directly, they observed nature closely, they learned through failure and survival. Modern construction often prioritizes speed and profit. Ancient construction prioritized permanence. That's why ancient structures are still standing, while modern ones crumble within decades. The greatest mystery isn't how ancient builders did it. The greatest mystery is why we forgot, and why it took us so long to realize what we lost.